请下一组上台。那 A36猫咪是流体，请到前面做准备。
Good afternoon, fellow judges and audiences. We have a video that demonstrates our hypothesis, and let me first inform you about our experiment. Our experiment aims to mimic the Earth gravitation in space via using a pendulum and a magnet. We will demonstrate our hypothesis through comparing the oscillation movements of our design experiment on Earth and in space. And here's the video.
How long will you try for the Asian Transparency Space Competition in part take? Hello everyone, we're here to try out for the Asian Tri-Zero-G space competition. My team is called Pendulumnauts. Now, introduction. Our experiment has something to do with pendulums and magnets, and we're gauging the effect of energy transfer and magnetic field effect in space. So our total time at max is going to be 10 minutes, which is going to be within competition standards, and 7 to 8 minutes minimum. And there's going to be a total of 14 members. So what our experiment is, we're gauging the effect of how magnets affect the pendulum when it's swinging. Is it going to slow it down? Is it going to speed it up? Or is it not going to have any effect at all? And if the pendulum ball is a metal, we don't have to worry that much because magnets will still affect copper balls and bronze balls. We just have to change the parameters of it. And will this be an easy way to create artificial gravity, which is what our main idea is about. So our factors are the string length, which is going to gauge the distance of magnet and the pendulum ball, which might be affecting the end result, which we are going to test as well, and which is that point. And air resistance on the ISS might affect the pendulum ball swinging as well, and friction of the line on the stick for the pendulum. Now, hypothesis. This is that in a microgravity environment, the oscillation motion of the pendulum will be significantly influenced by the strength of the magnetic field and the length of the pendulum string. As the magnetic field increases, the pendulum amplitude and frequency will vary in a predictable manner, which means the swinging pattern will be more and more predictable as the magnet becomes stronger. Now, a normal pendulum will be oscillation is limited as gravitational forces are acting on it. So you can see it, there is a set and there's limitations. While energy transfer decreases the amount of ball can use, causing it to slow down and stop, which means that some factors are taking the energy away and slowing the ball motion down, such as friction, air resistance, and momentum. Now, what we expect to happen on ISS with low gravity, like that picture, it's going to spin around and around and around, and low gravity on the ISS hints to zero to no gravitational forces affecting the ball, causing it not to lose momentum due to gravity, and the line restricting it, causing it to have a direction if we swing it in one direction, so it's going to change the direction as it goes, and expect it to stop either when it runs out of cord, because we don't have a ball bearing spinning with it, or friction stops it, which is a factor that isn't limited to space. Now, what we expect to happen when conducting the experiment, the pendulum ball behaves semi-normal while having a high oscillation, but remains mostly similar when we add a magnet to it. And while we don't have it, when we don't have a magnet, we expect it to go around and around and around. And a different string length will cause a huge impact on oscillation, such as oscillation length and oscillation time. So longer string length means a higher oscillation since it carries more momentum but less speed, and there's more resistance on the magnet. Now, procedure. This is our procedure. Items required: Node 5, Node 22, Node 23, Node 24, and Node 29. this is our original concept. Most things remain the same. The amount of time might be off since we added two factors in, and some other factors aren't included in this photo, but this is our original concept, and this is it.
Sorry for the video quality and volume, but yes, this is our proposal. Thank you.